standard deviation. And when we are considering the standard deviation, two terms are practically there. The first one is called the variance, and the second one is the standard deviation. And that standard deviation is the most used or widely used method for measures of dispersion. Now, when, that is in 1893, that standard deviation term was first proposed by Carl Pearson. And in statistics or any type of other, so much calculations are there where the standard deviation or the variance is very much important. In biochemistry, in normal astronomical unit, where each and every things are there, that standard deviation is a very important part calculation. And it is also based on the deviations of individuals from their mean. That means the standard deviation is also based on the mean deviation. Now, before the concept of standard deviation, that means when we are thinking or calculating the standard deviation, we have to first calculate the variance. That means we have to find out the variance at first, then the standard deviation. Let's check a very small example how we can find it. Suppose we have an example where x or each and every value of x has been given. So the values are given 20, then 15, then 19, then 24, then 16, then 14. And the total is given here, that is 108. So first of all, what we have to find out? Now we have to find out the mean. That means mu. 1, 2, 3, 4, 5, 6. 6 items are there. So 108 by 6. That one is equal to 18. So that is our mean. So what should be our next column? Next column would be xi minus mu. That means the each and every item its mean deviation. So the first of all, that is 20 minus 18 as xi minus 18 for that particular problem. So that one is my 2. Next one, 15 minus 18. So that is minus 3. 19 minus 18. That is 1. 24 minus 18. That is 6. 16 minus 18. That is minus 2. 14 minus 18. That is minus 4. So that is our second column. But we have to find out the variance at first. And for that, we have to find out xi minus mu, its whole square. So that means whatever is here, that is 2. That is 2 square. That is 4. That is minus 3 square. That is 9. 1 square, that is 1. 6 square, that is 36. Minus 2 whole square, that is 4. Minus 4 whole square, that is 16. Find out the total. That means summation of xi minus mu whole square, that is 70. So at that moment, what is the variance? Variance, how to find out the variance? We are not discussing about the variance at first. Variance can be treated as variance of x. That means whatever the values has been given in that notation is equal to summation of xi minus mu its whole square divided by n. So that one is equal to 70 by 6, and that is nearly equal to 11.67. Another one way that is most used, that variance x is written in the form of sigma square. That sigma, that sign is called the sigma, a Greek letter. Most of the used notation, sigma square, that is also the same meaning. Summation of xi minus mu whole square divided by n, and that is nearly equal to 11.67 for that particular problem. Now, what is the standard deviation? Now, standard deviation. Standard deviation is square root of variance or square root of var x or square root of sigma square or square root of whatever we have, xi minus mu whole square divided by n. But most important thing, each and every case, the plus is considered only. That means the sign plus is considered only. So we can say standard deviation or sigma is always positive. That means always plus sigma, never negative. That is the most important thing. So that's why we have written always the plus sign here. Suppose plus 4, any variance has been given as found, that sigma square has been found 4. So if we write sigma or the standard deviation plus minus square root of 4, so we can say, okay, that is plus minus 2. That is wrong. Always plus 2, never minus 2. Always positive. So here, according to that problem, the standard deviation, that means sigma, would be plus of square root of 11.67, that one, and that is nearly equal to 3.42, but always plus, never minus. That is symbolically. So another way of find out the standard deviation. So whatever the problem has been given, first find out the xi minus mu. That means at first the mu is there, mean we have to find out, then the individual deviations from the mean, then their squares, then the addition, and after the addition we find the variance, then we find the square root, but always positive, of that particular variance. Then that is our standard deviation.